Hi, my name is Sammy Hasten, and I'll be presenting my Lab 2 presentation today on the lines of charge lab. The purpose of this lab is still similar to Lab 1, where we want to see that everyday objects are usually neutral, but you can transfer the charge of another object to them. Again, with our two tapes, we stripped them, gave them a charge, and then they repelled each other. But unlike Lab 1, we need to see how the charges are evenly distributed across the tape rather than as a point charge like in Lab 1. And then we also need to find the electric force, net force, through superposition. And we find that by superposing, so adding together each individual charge electric force, and then we get our net force altogether. In this lab, we are evaluating the distributed electric force exerted on the top tape by the bottom tape in order to allow the top tape to float. So again, this is just looking at what the forces need to be in order to keep the system in equilibrium. And again, we're going over distributed forces rather than a point charge. And the result that I found was the electric force being 1.96 times 10 to the negative 3 newtons, and the gravitational force being negative 1.96 times 10 to the negative 3 newtons. And I believe this is correct because the system is in equilibrium because the electric force and the gravitational force are both equal in magnitude, opposite in direction. And if you look at the graphic below, you can see the red force being the electric force from the bottom tape on the top tape, and then the blue arrow being the gravitational force on the Earth on the top tape. The main physics principles used in Lab 2 were Newton's second law, which is just F net equals 0. This is saying that the system is in equilibrium. Newton's third law, which is for every action there's an equal and opposite reaction. We see this where there is the force exerted on the top tape by the bottom tape, and yes, as well as the principle of superposition, which is where we solve for each electric field separately and then add them all together at the end to get the net electric force on the particle. And pictured here is just a graphic of what the lab is doing. So we have the tape labeled A as the bottom tape, tape labeled B as the top tape, and the tape A exerts an electric force on the top tape, while the Earth exerts a gravitational force on the top tape, and altogether those cancel each other out and put the system in equilibrium. The measurements recorded were the distance between the tapes being 0.0028 meters, the mass of one tape being 2 times 10 to the negative 4th kilograms, and the estimated net charge on one tape to be 2.35 times 10 to the negative 9th coulombs. And below is just the general equation for a electric field of a line charge. And this is using the integral as well as distributing the integral and solving. Again, all of our measurements were solved via GlowScript. So I'm not going to go into much detail on how to solve that, but I will leave the generic equation just so you can see what my code was scripted after and how you would solve it if you weren't using GlowScript. This slide is showing the code that I wrote, and this is probably the most important section where it's creating those arrows for the distributed charges, as well as creating the electric force vector and the gravitational force vector. You can look into this more if you look at my GlowScript link, which will be attached to the YouTube video, but I'm not going to go into too much detail on the code right now. And pictured here, you can see the coding model for this lab. I have 15 different spheres, and the blue tape represents the bottom tape, tape A, and the red tape represent the top tape, which is tape B. The white arrow is the electric force exerted on tape B, which is the top tape, by tape A at the bottom, and the yellow arrow shows you the force of gravity on the top tape by Earth, or exerted by Earth. And if you look at the magnitudes of the arrows, they all are superposed together to create that one electric force, and the x components cancel out because there is the same arrow on the other side of the y-axis if you look at it. So through that you can see that there would only be a net vector in the y direction. So if you had modeled each of your tapes as a single point charge like in the previous lab, you would I found that the value of the point charge was less than the value of a line charge. And I think that these differ because the method using line charges is more accurate because you have more small points to add together, whereas the point charge is more generalized, which is 2 points. Thank you for listening.